In the depths of space, where darkness stretches for light years, huge molecular clouds lie hidden. These clouds are cold and massive, containing mostly hydrogen gas mingled with dust and other interstellar materials. For eons, they drift, seemingly quiet and formless, until the right conditions spark a remarkable transformation. Within the heart of one such cloud, gravity begins its subtle but relentless work. A region starts to collapse under its own weight, slowly compressing the gas. As particles crowd together, the density rises and friction builds heat. Invisible, yet inevitable, this process continues for millions of years, and the collapsing core becomes hotter and hotter. At a certain point, when the temperature reaches about 10 million degrees Celsius, something extraordinary happens. The heat is so intense that hydrogen atoms are forced to fuse, joining together to create helium. In this act, a tiny piece of the mass is lost, but not forgotten. It reappears as pure energy, blazing outward, following Einstein's legendary equation, E = tau 3 sines mc2. This newborn energy battles gravity. Gravity tries to pull everything inward, toward collapse, while energy radiates out, resisting that pull. For a while, the two grapple. Eventually, they settle into an elegant balance, a gentle equilibrium. The outward pressure from fusion exactly matches the inward pull of gravity. Where chaos once ruled, a star now shines. It lights up the surrounding space, marking the birth of something new and powerful. Every star you see in the night sky went through these same steps, from cold beginnings to fiery maturity. Our sun, too, was born from such a cloud. It was shaped and ignited in this cosmic dance billions of years ago, and its steady glow continues to power life on Earth. This intricate cycle of collapse, ignition, and equilibrium is how the universe crafts its stars, each a beacon formed from the darkness, a testament to the forces at work within the molecular clouds. Picture the life of a star as a grand cosmic tale, one marked by hunger, transformation, and destiny. It begins quietly in a cradle of dust and gas, deep within an interstellar cloud. Drawn together by gravity, atoms of hydrogen collide and heat up, igniting a brilliant nuclear fire. Thus a star is born. In the main sequence stage, its longest chapter, the star is steady and reliable. Deep within, hydrogen fuses into helium, releasing light and heat. For millions to billions of years, the star shines consistently, outward pressure from fusion balancing gravity's inward tug. This is when a star lives its prime, bright, vital, and at peace with itself. But fuel, even in the heavens, is not infinite. As hydrogen in the core dwindles, equilibrium falters. Gravity pushes inward harder. The core contracts, growing so hot that it begins fusing helium, or prepares to do so. Meanwhile, the star's outer layers, less bound by the shrinking core, balloon outward. The star swells into a red giant, glowing like an ember, its surface cooler and reddish compared to its youth. For stars like our sun, this transformation is dramatic, but not violent. The expanding outer layers are eventually puffed away by stellar winds, forming a delicate shell of glowing gas, a planetary nebula. At the heart remains the core, no longer burning, a white dwarf. This stellar remnant, about the size of Earth but much heavier, radiates residual heat and slowly fades over eons into darkness. But not all stars end so softly. For those born significantly larger than our sun, the story's finale is fierce and catastrophic. These giants burn through their fuel quickly, forging heavier elements in their core until iron is made, a dead end for fusion. The exhausted core collapses in an instant, and the ensuing rebound sends the outer layers blasting outward in a supernova. The explosion outshines entire galaxies for a brief moment, scattering newly forged elements into space. In the aftermath, something remarkable remains. If the core remnant is dense enough, it becomes a neutron star, a city-sized sphere of matter packed so tightly that protons and electrons have merged into neutrons. Stranger still, if the original star was truly massive, gravity wins so completely that the core becomes a black hole, a region of space where not even light can escape. Thus, the life of a star is a cosmic saga of fuel and transformation, shaping the galaxies themselves. Long after its death, a star's scattered ashes enrich future generations of stars, planets, and perhaps even life. Stars do not live forever, but their influence echoes across the universe. A massive star shines brightly in the cold expanse of space, burning its fuel for millions of years. It is a cosmic powerhouse, its core a furnace where lighter elements fuse to create heavier ones. But deep within, time is running out. The fuel that keeps its fiery heart alive dwindles, atom by atom. A moment arrives, brief, less than a second, when gravity claims victory. The core collapses in on itself, becoming unimaginably dense. Matter is squeezed tight, pressure ramps up, and then, in a violent instant, the core rebounds. This rebound sends a shockwave racing outward through layers of gas, tearing the star apart in a spectacular supernova. The explosion is not just a spectacle, but a cosmic forge. In the searing heat and furious energy, nuclear reactions churn, giving rise to new elements. Iron, gold, uranium, heavy atoms are fused together where moments ago only lighter ones existed. The force hurls them into the galaxy, spreading stardust across the universe. Far away from this celestial drama, a young planet forms from swirling remnants. Atmospheres build, oceans spread, and life emerges. Deep within every human body, within blood, bones, and cells, lie atoms once forged in the heart of an ancient star. The iron coursing through veins, the gold adorning fingers, the calcium forming bones, all bear the signature of a stellar explosion long ago. We look up at the night sky, seeking origin and meaning. But the stars are not just distant beacons. They are the architects of existence itself. Every breath, every heartbeat, every thought is a cosmic legacy. The universe is not separate from us. We are bound to its history, composed of its most creative moments. Thus arises an extraordinary realization. We are not mere distant observers of the cosmos. We are inheritors of its power, its destruction, and its beauty. We are products of stars, carried forward by their light, destined to contemplate both their fate and our own. In a quiet village, miles from the city's lights, Maya stood on her porch and gazed at the star-strewn sky. To most, the pinpricks overhead were mere decorations, trembling in the night's silence. But for Maya, each star told a deeper story. She remembered her grandfather's words. Every star is a nuclear furnace, fusing atoms and forging light. Those specks, however distant, were not mere lanterns. Each was a colossal engine in turmoil, its core hotter than imagination could grasp. In her mind, Maya followed one of those stars through time. She saw it begin as a cloud of gas and dust, gravity coaxing it into existence. In its blazing core, hydrogen smashed into hydrogen, becoming helium. From there, heavier and heavier elements formed: carbon, oxygen, iron, the building blocks of planets, oceans, and living things. She imagined, too, the star's inevitable end, a titanic explosion, a supernova casting its guts into space. In that violence, even more exotic atoms were born. Over millennia, those scattered elements drifted and mingled, eventually drawn together by gravity once again. A solar system spun into being. Planets coalesced. And on one tiny world, life began, built from that same stardust. Maya breathed in the cool air, conscious of the unity in all things. The iron in her blood, the calcium in her bones, the oxygen filling her lungs, all had once blazed in the heart of a star many ages ago. She smiled, not with cosmic pride, but with humble amazement. To look up at the night sky was to see not only distant fires, but the ongoing birth, death, and renewal of all that is. The stars above were not the universe's ornaments. They were its memory and its promise, the reason she stood there, alive and searching for meaning in the constellations.